Hello everyone. Today in this video we'll be covering Sp2 hybridization and Sp hybridization. In the previous video we covered Sp3 hybridization. Now Sp2 hybridization, the first thing to notice is that the shape that it is consistent with strignal planar, which means that it should have 3 bonds, right? Now one of the carbons must have a double bond with another carbon. So we should already know that the carbon-carbon double bond is made up of one sigma bond and one pi bond. Okay, and we'll look at what each of these types of bonds play towards the entire structure of the compound and the electron sharing. Now in the ground state, again we are familiar with the diagram of the electronic configuration, and similarly in the excited state it is the same thing. Now in the hybrid state it is different in this case. What happens is the 1s orbital will have a similar configuration. Again, now what basically occurs in this is that the one of the s orbitals of 2s and 2p orbitals from the 2p subshell come to an intermediary level over here in between, and they form the sp2 hybrid. So let's mark that. This is the sp2 hybrid, and the third p orbital remains at the same level as it was because it has been untouched. Okay, now let's write down the electronic configuration of these. So the 2s orbital has one electron, so this will also have one electron, and each of the p orbitals also have one electron. So all of these will look like this. Okay, so this is the unhybridized orbital, and in the middle we have the sp2 hybrid. Now how exactly this plays towards the structure, we will just look at that right now. So over here we use the example of C2H4, ethene. Why do we use that? We use it because we know the structure of ethene is something like this. We have two carbons bonded to each other by a double bond, and we have two hydrogens bonded to each of the carbons. Now the structure that I've drawn for ethene looks sort of complex, but once we analyze it, it'll become easier. So again, I have color coded each of the type of bonds, so that'll make it easier. The red circles are your s orbitals of the hydrogen atoms, and they are bonded to these sp2 hybrids. This, and this. The green ones are your sp2 hybrids. The two orbitals over here form a sigma bond with each other. Okay, so this is a sigma bond in between. And these yellow ones, do you see these two yellow orbitals coming out of each of the carbons? They basically form a pi bond between each other. So a simplified diagram can be seen over here. So this is your sigma bond, the one that I'm marking, the straight line, and these two kidney shaped substances over the sigma bond and under it are basically your pi bonds. So one pi bond is one pair of kidney shaped things. Okay, so this is your pi bond, and that is basically whatever there is in sp2 hybridization. The second type of hybridization that we'll be doing in this video is your sp hybrid. Now an sp hybrid, first of all, the shape that it is related to is a linear shape, and it is consistent with the carbon-carbon triple bond, which is made up of one sigma bond and two pi bonds. Again, the ground state and the excited state are similar to whatever we've done in sp3 and sp2. The hybrid state structure, however, is different. So let's look at that. Similarly, the 1s orbital will have similar electronic configuration. Now what happens is that the 2s orbital and one of the 2p orbitals come to an intermediary over here in between at an energy level, and two of the 2p orbitals remain at the same energy level as they were before. So this is the sp hybrid, and these are the unhybridized orbitals. Now let's look at the electronic configuration. Again, the 2s orbital has one electron, so the s will have one electron, and each of the p orbitals have one electron, so all of these will have one electron each. Now how exactly this looks in a structure? The structure will look somewhat complicated. Okay, so let's take it slow over here. The example that we'll be using is C2H2. It is called ethine, and it is an alkyne, right? Now the simplified structure is drawn on this side, so you could look at that first. We can see that there is a carbon-carbon triple bond, and we can also see that one hydrogen is bonded to each of the carbons. Now again, I've color coded the bonds so it's easier for you to notice. First, the red circles are just the s orbitals of the hydrogens. The green are basically your sp hybrids. Okay, so this is your sp hybrid. Then they are forming a sigma bond in between, which I've just denoted right now. Now there are two pi bonds. We just discussed that, right? There is one sigma bond and there are two pi bonds. So the sigma bond was discussed. It's the green overlap in between. The two pi bonds are what we see over here. We can see, now I'll be marking over here, and it might seem sort of messy, but do notice it. The two yellow ones over here, they are forming one pi bond between each other, and the two blue ones over here, they are forming another pi bond. You can notice by the white parallel lines that are drawn. So there are two pi bonds in total. Okay, so this is sp hybridization. All you need to know for hybridization is that sp3 hybridization has a shape of tetrahedral, and the bond angle is 109.5 as discussed before in shapes of molecules. sp2 hybridization is trigonal planar and 120 degrees, and sp hybridization is linear and 180 degrees. That is all that you need to know for AS chemistry hybridization. Thank you.